Welcome back to the DNaz channel. I am your host, DNaz. Today we are going over some Earth science. That's right. Recently, I did a live session where I was teaching some Earth science. And some of you might be like, how the hell are you qualified to teach Earth science? Well, I'm probably not, but I do have a degree in environmental science. So I think that's going to qualify me to say some shit, right? And I work hard on my studies, people, right? And I am still in college. So that's that. I have a bunch of notes taken about our beautiful Earth, our wonderful blue planet, right? And I got shit to say about our solar system. And number one thing I want to get across right from the jump, Pluto's my boy. Pluto is my boy, and I count Pluto as a planet still. I don't care who Neil deGrasse Tyson is. I don't know who the hell he even thinks he is when Pluto's been in our solar system, according to our ancestors, for 10,000 years. It's been recorded. And all of a sudden, this guy wants to come along and just go, well, he's not big enough. What are you going to do? Pick on our little brother all the way out there in the cold? All the way out there? You want to pick on him? Because you got no one better to pick on? Neil, right? So screw that. Screw you, Neil deGrasse Tyson, my ass Tyson. Pluto's my boy, and Pluto is staying right with us. I am bringing Pluto back into our solar system. I'm DNaz. If you haven't heard of me, Neil deGrasse Tyson, hear from me now, hear about me now. Pluto's coming back into our family. All right? So, now that I went on my little rant, let's get into Earth science, baby. Let's get into it. So, what is Earth science? It is the name for all the sciences that collectively seek to understand the Earth and its neighbors in space, right? Okay, so Earth science includes geology, oceanography, meteorology, and astronomy, okay? So we deal with processes and phenomena that vary in size from the subatomic scale all the way to the infinite scale of our universe. So this was another point I was making in my live session because I heard something beautiful the other day. I heard, remember when we used to try to sail around the world and we didn't know that the Earth was spherical? We didn't know. We thought the Earth was flat, or we thought like you just fell off at some point, right? We didn't know that you would go keep sailing and sail all the way back around to the same place you were, right? Imagine if space was like that. Imagine if space is so big and is actually a sphere, but we don't know it because it's so big we can't see that far, right? We could see almost 14 billion years into the past. That's amazing, number one. Okay, humans are amazing. That's another reason why I don't buy the whole alien spiel that aliens seeded mankind, aliens built the pyramids. No, humans did that because we are amazing, and we could see 14 billion years into the past because of how we can track light, because of how good our science is, thanks to Aristotle for inventing our scientific method, right? So geologic time is the span of time since the formation of the Earth, which is 4.6 billion years ago. So the Earth has been around for 4.6 billion years, okay? Probably 4.7, 4.8 now. These are old notes. So geology means the study of Earth and is divided into physical and historical, right? Earth is a dynamic, ever-changing planet where there's internal forces like earthquakes, volcanoes, and mountains, like mountains that get built. These internal forces are generated from the center of our Earth, which is molten iron, right? and probably some nickel. We don't know 100%, right? We know about our tectonic plates, which are plates that are either convergent or divergent. So if they're convergent, they're going like this, pushing up against each other, and that's how mountains form, okay? But that's also how volcanoes are forming. And then the lava spewing out from the center. So we know it's hot down there, right? We have technology to measure the heat coming out of the core of our Earth. So we know that all that stuff is happening. And that is our internal forces, right? Then we have our external forces. Our external forces break rocks apart, they sculpt landforms, and then you have erosional effects of water, wind, and ice, okay? Creating different landscapes. Next we have meteorology, we have oceanography, I told you that, astronomy, right? And then we have environmental science. That is one of our other science, right? That is where I step in. Environmental science is an interdisciplinary program, okay? That's a word to know, interdisciplinary. That means you're combining all the different studies, biology, chemistry, you're combining the sciences to make up one science. So environmental science is a study of our Earth and how organisms interact with our Earth and live here, and the effect we have as humans on our planet, okay? So pretty much it's the relationship between people and the natural environment, okay? So the early evolution of the Earth, right? The nebular theory, that's our main theory. The nebular theory is where the formation of our solar system was like a disk. After the Big Bang, gravity pulled things together like a disk and started forming all of our planets, right? The sun began forming like 5 billion years ago, and it was a large cloud of dust and gases, right? Again, that get pulled together, right? So as the cloud contracted, it rotated faster and assumed a disk shape. Material that was gravitationally pulled toward the center became proto-sun, okay? Within the rotating disk, solid matter gradually cohered to form objects called planetesimals. Our universe beginning was about 13.7 billion years ago, right? And we have the Big Bang Theory, where everything exploded into matter from tiny dimensions to huge dimensions, okay? And as the universe continued to expand, it cooled and particles condensed to form hydrogen, helium gas, and I believe methane, right? But definitely hydrogen and helium gas that cooled and clumped together to form the first stars and galaxies, okay? Then we have the circumference of the Earth, okay, which is more than 25,000 miles. Our Earth is 25,000 miles around. That's amazing, okay? It's huge, huge. The sun is like 109 times. That I know. The sun is 109 times the size of the Earth, okay? The distance between the sun and the Earth is 1 astronomical unit. All right. After the forming of the sun, ending in contraction and gravitational heating, the area of the inner planets' temperature decreased, causing substances with high melting points to condense into tiny particles that began to coalesce. Okay. Materials such as nickel and the elements of which rock-forming minerals are composed. Silicon, calcium, sodium, and more form metallic rocky clumps that orbited the sun. Repeated collisions kept happening, and these planetesimals started forming, and it formed our 4 inner planets: Venus, Mars, Earth, and Mercury. Okay? Now, my notes here say the 4 outer planets, but let me be clear. I'm going to say the 5 outer planets because, again, Pluto is our brother. Okay, so the 5 outer planets: Jupiter, Saturn, Uranus, Neptune, and Pluto formed with percentages of high ice percentages, okay? Due to lower temperatures far from the sun, these ices are water, carbon dioxide, ammonia, and methane, okay? Which all combined with rocky and metallic particles, and the accumulation of ices account for, in part, for the largest size and low density of these planets. Earth's physical system is traditionally divided into three major parts: the solid Earth, called the geosphere, the water portion of our Earth, called the hydrosphere, and Earth's gaseous envelope, which is our atmosphere. There is a fourth sphere of the Earth that is called the biosphere, okay, which is the totality of life on Earth. Of all the water on Earth, 97% is in the ocean, and the ocean covers 71% of the planet's surface. Our ocean also goes as deep as 12,500 feet. The distribution of water in the hydrosphere is 96.5% oceans, 2.5% fresh water, 1.72% glaciers, and 0.75% groundwater, with all other fresh water being 0.03%. And our saline groundwater is 0.9%, and lakes included, okay? 69% of all of our fresh water is locked up in glaciers. So you might hear me preach about global warming and this, that, climate change. Yes, I think we do have an effect. Do I think that we are going extinct from it? No, I just love our planet and I don't want us to affect it as much as we are, right? But if those polar caps start melting, there's more fresh water for us. There's 69% of our fresh water is locked up in those caps. We'll be fine. And not to mention, see, this is where people went nuts when I was talking about global warming and climate change on TikTok and YouTube. They were going nuts, like, oh, you believe that, blah, blah, blah. Not everything about it is real, okay? Like those wind turbines that are sold to us from China, but you see China doesn't have any of those fans, right? Things like that, the going green movement, things like that were over-exaggerated, but that doesn't mean that we don't have an effect on the planet, right? So, again, all that fresh water locked up in glaciers. Oh, and our dioxide levels, right? Our carbon levels, which is where our greenhouse gases come from. Our greenhouse gases come from us burning fossil fuels like gas, you know? But at the time the dinosaurs were alive, there were primates alive. And our parts per million of our carbon was way higher than it is now. So, you know, we can definitely live under higher circumstances. It's just not beneficial for us, okay? So, this was lesson 1 of Earth Science, people. This is lesson number 1. We have a lot to go over because the Earth is very vast, okay? I'm only on like two pages. I have all these notes for you guys, okay? These are notes I took from my classroom. Typed them myself, okay? So if you want to come back for more Earth Science, you'll get it the next time I make an Earth Science video, baby. So you've been watching the DNaz channel. I hope you like and subscribe and come back for more. And we will see you next time.